So, for this part of our talk about trigonometric inverses, this video refers back to two videos prior where we talked about the inverse of a function or the function of an inverse, which is another way of saying a composite function. So let's remember that earlier that the inverse of a function gives you x, and the function of an inverse also gives you x. Now these linear relationships had absolutely no restrictions, but trigonometric functions do. So let's use this table to kind of help us out a little bit and put things in perspective. So let us get to my blue pen. And let's first of all talk about the three trig functions we're going to focus on today. We're going to talk about sine and cosine and tangent. Now the inverse cosine the inverse sine always has you go find a location. So if you take the inverse sine of x, the answer is x. But this is only for quadrants 1 and 4. So if your sine of x is not in quadrants 1 and 4, you have to make sure they are there, because the inverse of sine is restricted to quadrants 1 and 4, or between negative square root of negative pi over 2 to pi over 2. Now the inverse cosine is also looking for a location, and the inverse cosine of the cosine of x is going to give us x, as long as we're looking in quadrants 1 and 2. And that's because the restrictions of the inverse cosine is between 0 and pi, or between, quadrants 1 and 2. The inverse tangent, if I want that location of the tangent of x, my answer should be x, and that's only if I'm in quadrants 1 and 4. Because tangent only exists between negative pi over 2 and pi over 2 exclusively, which means it can't actually be those because those are asymptote lines. So these three parts of this table is for problems 12, 13, 14, and 15. So we're going to find the exact value. And I am going to put a line across here because you'll note that anything below this starts with the function and goes to the inverse. So this first section is inverse of the function, and this next section here, which I'm going to do in a different color than blue, is going to be the function of the inverse. Okay, so I ask myself, is pi over 10 in the first and fourth quadrant? And it is. It's in the first quadrant because it is less than pi over 2, and therefore the inverse sine of sine is that location in the first quadrant. The second problem I ask is that, is the inverse sine of sine, is this negative 3 pi over 7 in the fourth quadrant? Because sine can exist in the first or fourth quadrant. And it is, because the negative 3 pi over 7 is less than negative pi over 2, so it's in the fourth quadrant, so you have negative 3 pi over 7. So you're now getting into the pattern of saying, like, wow, so these signs cancel out? I mean, that's kind of one way to look at it. I wouldn't use the word cancel, but maybe use the word simplify. But things get a little trickier if you go to problems 14 and 15, and you're just telling me that, oh, it looks like the answer to this is negative 5 pi over 3, and the answer to this is negative 2 pi over 3. Well, that's incorrect, and the reason why it's incorrect is because the negative 5 pi over 3 is not in the first or second quadrant until you convert it. Now, you might be saying, yeah, but, let me take a look at 5 pi over 3. 5 pi over 3, if I go negatively, takes me all the way around to here. So it technically is in the first quadrant, because the terminal side is in the first quadrant, and that negative 5 pi over 3 lands here at pi over 3. Well, that is going to be the answer to this problem. The answer is pi over 3. And it's pi over 3 because pi over 3 is in the first and second first quadrant, which falls within the first and second quadrant. This negative 5 pi over 3 traveled to places where it could not go, which is not in the first and second quadrant. So this is why this is the correct answer and not this. So this is very important. You have to make sure when writing down your answer that your answer literally is in the quadrants that it's supposed to be talking about. Which brings us to a little bit of a tricky problem here, because now I'm going to look at negative 2 pi over 3. Now negative 2 pi over 3, I mean, again, let's go take a look at this on a unit circle here. Negative 2 pi over 3, and granted, if I went positive 2 pi over 3, I'd go a positive 120 degrees. So this is negative 120 degrees. So this is the movement of negative 2 pi over 3, which means that here's my angle. And my angle's in the third quadrant here. So the big question is can I go, 4 pi over 3, can I go all the way here? Well, I can't do that either, because 4 pi over 3 and 2 pi, negative 2 pi over 3, they both leave either the first or the fourth quadrant. So what we have to do is find a reference angle to the 4 pi over 3 that is in either the first or the fourth quadrant. So let's see here. What angle would be the reference angle to 4 pi over 3? This is, if we took a look at its measurement from there to there, this is our 60-degree angle. Okay, those are 60-degree angles. So the reference angle in the first quadrant would be pi over 3 again. This is pi over 3 here. And so my answer is pi over 3. Another way you could have looked at that problem is you could have said this. You could say here, the tangent of negative 2 pi over 3, so I'm going to show you another way to have done this problem instead of this graphic way. The tangent at negative 2 pi over 3 is the tangent at 4 pi over 3, and that tangent is square root of 3. Now you'll note that the square root of 3 can only exist in the first quadrant or the third quadrant, and luckily, since it exists in the first quadrant, take a look where the inverse tangent is square root of 3 in the first quadrant, and it is at pi over 3. So problems 14 and 15 are tricky, and please, if you encounter a problem like this in your homework and need me to kind of show you different multiple ways to find this out, I'd love to do it. So we're done with that example. Now, and remember, these are all the examples of we had the inverse of the function. The inverse of the function, or the inverse function of the function, always gave you a location. So for these problems here, this is going to be the function of the inverse function, and this is going to give us values. So if I have the function of the inverse function of sine, I'm going to get x. And that's only if your answer is between negative 1 and 1. Because we have to look at these values that the inverse function exists. And again, you could have seen that if you have our sine wave or our cosine wave, and it's hard to tell if a sine or a cosine. It all depends on where you put your x-axis, right? But essentially, these sines and cosine waves only go from negative 1 to 1. So the same thing goes for cosine. Cosine has the cosine function of its inverse function is going to give you x, negative 1 to 1. So luckily for us, the function of the inverse function of tangent has no restrictions. It's equal to x for all real numbers, or if you wanted to write negative infinity to infinity. So here's what's great about that. If we scroll down to the problems at the bottom of this page, see? The tangents have absolutely no problems. So here the tangent is negative 2, because the function of the inverse function is itself and has no restrictions. And the same thing goes here, 10. Because the tangent lines, the inverse tangent graph looks something a little like this, where this is the y-axis here. And so it can go on forever and ever. So it exists at 10, it exists at -2, so that line just keeps going and going and going. So let's talk about problem 16. Is the -2/3 between -1 and 1? It is, so you have it. Your function of the inverse function is itself if and only if you are between -1 and 1. Now how about sine? Well, in this case, it does not exist. And the reason why it does not exist, it's because it's not between -1 and 1. And number 19 also does not exist, because the function of the inverse function only works if this is true, and it's outside of the range of where it can exist, so therefore, actually I should say domain of where it can exist, and it basically just can't work. So that ends this video, and in the next video we are going to solve for more inverses of functions. You're going to need your unit circle, and you're going to need your Pythagorean theorem. Thank you very much for watching.